Now, hello and thank you for watching this video on compound inequalities. Like usual, my disclaimer before watching this video is make sure that you have this assignment completed and all you're doing is just checking again that your answers are in fact correct. So we're going over compound inequalities, and on this example, we're going to have two types of inequalities with the ones that say and the ones that say or. We're going to do a couple of the or ones, and then we'll go to the and one. So here, what we have is that we have two separate equations, okay? We have this one here, and then we have this one right there. So we solve each equation independently. So using inverse operations for the one that's on the left side, we have to add 6 to both sides of this inequality. Let me highlight the inequality in yellow of that symbol right there. And we're going to cancel these two operations, and we left with negative 4n is greater than or equal to negative 4. Dividing by negative 4, n is going to be less than or equal to 1. Now recall that anytime you divide by a negative value, your inequality has to change direction. So our solution is going to be that. Now we do the same thing with the next example. We subtract 9 from both sides, and 5n is going to be greater than or equal to, let me erase this so it doesn't look like we're dividing, okay? We're going to subtract 9 from 44, and that's going to equal to 35. We divide by a positive 5, and n is going to be greater than or equal to 7. So here are the two solutions. Now remember, I want you to write the solution in interval notation, okay? So here, if we look at it as a graph, the values of n are less than or equal to 1, and then greater than or equal to 7. So our interval notation is going to look like this. It's going to go from negative infinity to positive 1 using brackets on the 1 and parentheses around the negative infinity. And then we're going to go with brackets on the 7 to positive infinity. So this is our solution. Now for number 2, we'll add 8 to both sides, and negative 8r will be greater than 48. We divide by negative 8, and r switches this inequality symbol because we're dividing by negative 8 to less than negative 6. So now for this equation here, we're going to add 7 to both sides, and negative 8r is less than negative 40. We divide by negative 8, and r would be greater than positive 5. So negative 6, 0, 5 right there. Again, I'm not drawing this number line to scale, okay? So because of no equal sign, there would be an open circle, and all the numbers to the left less than 6, open circle on 5, and all the numbers greater than 5. So as an interval, we will go from negative infinity to negative 6 with parentheses around both of them. And then we would go from positive 5 all the way to infinity, again using parentheses. So that would be the solution. For number 3, this is an AND equation. So with an AND, that means that the solution is going to go from one number. It's going to start at a number and go towards another number, and they're going to meet up. So it's going to be other numbers in between, okay? So remember, that's the difference between ORs and ANDs. With the ORs, you're going to have the solution, again, go in opposite direction. So all the numbers to the left and to the right, all the numbers to the left and to the right. But with an AND, they're going to go towards each other, okay? So we'll have to solve the two equations again separately. So we'll subtract 7 from both sides for the first equation, and 7m is greater than negative 7. We divide by a positive 7, and even though we get a negative value, this inequality is not going to flip. Notice that I didn't flip it, I kept it the same. Now for the second equation, we're going to subtract 3 from both sides. So negative 10m is greater than or equal to negative 30 and dividing by negative 10, m will now be less than, because we're dividing by a negative, so that's going to switch to positive 3. So on our number line, we have a point from negative 1 to positive 3, and it's an open circle on the 1 and a closed circle on the 3, and they're going to go towards each other. They're going to connect. So our interval will look like this. It will be a parenthesis on the negative 1 and a bracket on the 3. Now this is also an example of an AND inequality. So we're going to write it in the following form. We have negative 80 is less than 7n minus 10, and we have 7n minus 10 is less than 18. So we're just going to separate it. So we solve the two equations. So here we're going to add 10 to both sides, and negative 70 is less than 7n. We're going to divide by 7, and negative 10 is still less than n. So for this next example, for the other equation, we're going to again add 10 to both sides. 7n is less than 28. We're going to divide by 7, and n is less than 28 divided by 7. So here, just so you could get a picture of this, again, it's not drawn to scale. 0 would obviously be somewhere right here in the middle. We would have an open circle around 10 going towards this other number, and an open circle over 28 over 7 and go in that direction. Now 28 cannot be divided by 7, and they do not have a common factor. Oh yes, I'm sorry, 28 can be divided by 7. That's equal to 4. Sorry, I had a little mental break there. 28 divided by 7 is equal to 4. So I could write this as 4. Sorry about that. So again, going back to what I was saying, because there are no equal signs on either of them, that means that we're going to have open circles on the two numbers. So to represent this on interval notation, we will write it as negative 10 to positive 4 with parentheses on each one of them. Now, again, here's another example of an AND. Again, because we have something in the middle and we have less than and less than. One is less than the equation, the algebraic expression, which is less than n 11. This is an example of an AND. So we split it up, and 1 minus 10x is less than 11. So we're going to subtract 1 from both sides. That means that 0 is less than negative 10x. We divide by negative 10. And again, because we're dividing by a negative number, this inequality is going to change. So 0 would be greater than x, okay? Now we do the exact same thing over here. We subtract 1 from both sides. This gets eliminated. Negative 10x is less than 10. We divide by negative 10. And x, again, because we divide by a negative number, this is going to flip. We're dividing by a negative 10. That's going to be greater than negative 1. So on our number line, negative 1 is to the left of 0, right? Even though this one is first, that one goes actually right there, okay? So we're going to put them going towards each other because, again, it's an example of an AND. And every AND inequality, again, connects the two endpoints. So here, our interval notation would be negative 1 to 0 using parentheses. So this would be the solution. This is an OR, so obviously the number line will look something like this, regardless of what the numbers are, okay? It's going to end up looking something like that because it's an OR inequality. So let's solve for it. So for this one, we'll start on the one on the left side of the OR. We'll add 8 to both sides, and 4a would be less than or equal to, what is that, 32, negative 32. We divide by 4, and a is less than or equal to -8. So again, even though I do have a negative value, I am not going to flip this inequality because I'm dividing by a +4. So that is not going to flip that inequality, okay? So that's going to stay the same. Now for the other equation, for this equation over here on the right of the OR, on that one right there, we have to add 7 to both sides, and -1a is less than or equal to -10. We divide by -1, and the value of a is greater than or equal to +10. So again, you see, we flipped it because we were dividing by -1. So as a number line, -8 is to the left of 10 on the number line, and we're looking for the numbers less than or equal to -8, so that would use a closed circle, and we're looking for the numbers greater than or equal to 10, so that would use a closed circle. So as an interval notation, we will go from -infinity to -8 using brackets on the 8 and a parentheses on the infinity, -infinity, and then we will go start from 10 and go all the way to +infinity using again brackets and then parentheses. So this right here would be your solution. All right, sorry. Okay, let me zoom out. That's what I was trying to do, zoom out. So let's go to the back page now. So on the back page, we're going to solve this again, another OR example. So we'll subtract 4 from this equation, and 4b would be greater than or equal to 4. We divide by 4, and b is greater than or equal to 1. Now for the one on the right, we subtract 2 from both sides, and 10b is less than -20. We divide by 10, and b is less than -2. So again, even though this one is first, it was on the equation first, on the number line, -2 is to the left of +1, okay? So make sure you put those numbers accordingly to the number line. So -2, 0, and then 1 would be to the right. Because again, we write these things on the number line from least to greatest. So here, we're looking for the numbers that are greater than or equal to 1. So using a closed circle, that will go to the right. And all the numbers less than or equal to less than -2, that would be an open circle and to the left. And again, they're pointing in the opposite directions of each other because again, it's an OR. So in an interval, we would start from -infinity, go all the way to -2, use parentheses on both of them, and then we would use, brackets, we would start at 1 and then go all the way to +infinity. So for this and, again, it's an and inequality, compound inequality. So that means on the number line, the graph is going to look something like this. We'll have some solution, some other endpoint, and they're going to connect. They're going to go towards each other. All right, so let's figure out what those numbers are. So we'll subtract 4 from both sides. 2r will then be greater than -18. We divide by 2, and r is greater than -9. Again, notice I did not switch. I did not switch it because I am dividing by by a positive, I'm dividing by a +2. So that is not going to switch. For this one, we will add 6 to both sides, and 10r is less than or equal to 10. We divide by 10, and r is less than or equal to 1. So on the number line, -9, 0 would be somewhere in the middle, and 1 would be somewhere around there. Again, it's not drawn to scale, and I'm not trying to draw it on scale on my number line. I just want to know that I have the numbers in order from least to greatest. So on the 9, we would use an open circle. On the -1, on the +1, we would use a closed circle because of that, because of this equal sign right there. And again, we would connect them together because the numbers greater than -9 are to the right. To the right. And the numbers less than 1 are to the left. So the graph will look like that. But I want my answer in interval notation, so I would use a parentheses on the negative 9 and a bracket on the positive 1. So for number 9, this is again another example of an AND. So I'm going to split this up. So we have negative 3 is less than or equal to 7 minus 2n, and 7 minus 2n is less than 23. So on both equations, I would start by subtracting 7 from both sides. So negative 10 is less than or equal to negative 2n, and I would then divide by negative 2. So 5, but now since I'm dividing by negative 2, this inequality is going to flip. So 5 would be greater than n. Now I do the exact same inverse operation to the other equation. Negative 2n is less than, what is this going to be? 23 minus 7. Gosh, I am having a mental fart. So 23 minus 7, that's equal to 16. 16, yes, okay. Sorry about that. I divide by negative 2, okay, and n will now be greater than negative 8. So on my number line, negative 8 is less than 5. 0 would be obviously somewhere in the middle. And above each number on negative 8, we would use an open circle because there is no equal sign. And on the 5, we would use a closed circle because this one doesn't in fact have an equal sign. And because it's an and, that connects the two, that makes them go towards each other. So as an interval, we would use a parentheses before the negative 8. And since 5 would be where we end, that would go second. And we would use a bracket on that one because of the closed circle. Another and, so I would add 9 to both sides, and 8n would be less than 0. Divide by 8, and n is less than 0. Here I would add 5 to both sides, and n would be greater than negative 10. Since this is in a 1, dividing by 1 really doesn't make much of a difference, but I'm still going to, again, do that step. So I divide by 1, and the value of n would be greater than negative 10. So on the interval, negative 10 is smaller than 0. We would have open circles on both of them, and all the numbers greater than negative 10 and less than 1 are in between. And again, that's because we have an and compound inequality. So as an interval, we would use parentheses on both numbers, on negative 10 and on 0. All right, let's see, we only have these last two remaining. So we would add 5 to both sides, and a would be greater than or equal to 9. And again, dividing by 1, that doesn't change much because there's a 1 right there. So that's not going to change what the solution is. Now for this other one right here, we would add 4, and 8a would be less than negative 40. We divide by 8, and a is less than negative 5. So on the number line, again, regardless of which one you did first, you're not going to put 9, then negative 5. That doesn't make any sense on the number line, okay? So you have to write the number line correctly. So negative 5 goes first, 9 goes second. That's an or, so these should be pointing in opposite directions. On the 5, we would have an open circle going to the left because we're looking for all the numbers less than. And on the 9, we would use a closed circle and pointing to the right because we want all the numbers greater than. So as an interval, you would start with parentheses and go from negative infinity to until we get to negative 5 and close the parentheses. And then we would then continue from 9 all the way to positive infinity. Oh, but I need to fix something here. We would have to use a bracket, okay? We'd have to use a bracket and not parentheses because we have the closed circle on the 9. And finally, for the last one, this is an OR, so we should have that the endpoints point towards each other. So we would add 4 to both sides, and 9n would be less than 90. And dividing by 9, n is less than 10. Here we would subtract 4 from both sides, and 6n would be greater than or equal to 18. Dividing by 6, n is greater than or equal to 3. And again, we're not going to write this as 10 and then 3. That doesn't make sense on the number line. We have to write the number line again appropriately. 3 is smaller than 10, so on the number line 3, we should go first and 10 second. Above the 3, we would have a closed circle, and on the 10, we would have an open circle. And again, because it's an and inequality, they will go towards each other. So our interval would start with a bracket, go from 3 to 10, and finish with a parenthesis. So this would be the interval notation to that right there. So there you go. Again, as usual, disclaimer is that you are just simply checking your answers and not just copying the answers here, okay? So again, thank you for watching. We have tutorials on every Wednesday, and I hope this was very helpful. Again, thank you for watching and have a good day.